So we're going to now use this property right here that we mentioned at the end of the last video to solve some of these exponential equations. Okay, so for example here, it's maybe not clear how to do this one. Actually, we don't really need exponents or logarithms for this one. We could also just say this is 10 to the 10x, 100 is 10 to the 2. Since we have the same base and these numbers have to be equal, then that means the exponents would also have to be equal too. And so we can just set the exponents equal. And then divide both sides by 10. You get x equals 2/10 or 1/5 as your answers. Now with logarithms though, we take the log of the left-hand side and the log of the right-hand side. We can use our properties here. The log and the 10 cancel, and we're left with 10x. And log of 100 is 2. And again, we divide both sides by 10. And x is 1/5 or 2/10 again, right? So it's the same answer, right? Same answer. B, we can do something similar as well. We don't need logarithms to answer this. We can just say this is 10 to the x minus 1. 1 over this is the same as 10 to the x plus 1 raised to the negative 1, like that, right? If you have 1 over a exponential like that, then you can just use a negative 1 exponent to make it the reciprocal. Distribute that negative 1 power then, and so we'll have 10 to the x minus 1 equals 10 to the negative x minus 1. And this again, it's to the same base, and the numbers have to be equal. That means the exponents would also have to be equal. Okay, which would then mean that x minus 1 equals negative x minus 1. Okay, add the x over, add the 1 to over, and we'll have 2x equals 0, or x is 0. Okay, alternatively, you could use logarithms here and do log of 10 to the x minus 1 equals log of 1 over 10 to the x plus 1. Okay. In this case, right, we have a division here. Now, we haven't talked about division problems, but if you do take the log of like something like x over y, that is equal to log of x minus log of y. In the same way that log of x times y is equal to log of x plus log of y, right? So when you multiply, it becomes addition. When you divide, it becomes subtraction between two logarithms. So here, this will cancel, we'll have just x minus 1. And then over here, we'll have log of 1 minus log of 10 to the x plus 1. Log of 1 is 0. And then minus, and then those will cancel, and we'll have minus x plus 1. So the minus will distribute. So we'll have x minus 1 equals negative x minus 1. And you can see we have the exact same thing there. So it'll simplify to be x minus 0 as well. X equals 0 as well. Okay? Let's do this one. All right. So again, you can rewrite both of these as powers of 10 if you want to, and then negate having to use a logarithm at all. But we'll go ahead and endure without. Well, we can show that both ways. So 100 we can rewrite as 10 to the second to the 2x. And this is 10 to the 3x minus 1. Okay. Why don't you guys go ahead and try and simplify it from here, since I've got it set up for you there. Try and solve from there. Okay. So hopefully you tried it here. A power to a power, we can then just multiply. It becomes 10 to the 4x equals 10 to the 3x minus 1. Okay. Same base. They're equal. So that means the powers have to be equal. Okay, subtract 3x from both sides. You get x equals negative 1. Alternatively, okay, if we take a log of both sides, then we can bring that 2x out front, and we'll have log of 100. And we can bring the 3x minus 1 out front, and we'll have log of 10. Okay, log of 100 is 2, so it's 2 times 2x, or 4x. And in this case, it'll be log of 10 is just 1, so we'll have 3x minus 1, which is exactly what we had over here. And so we have x equals 1, negative 1 when you solve there. Okay? All right, we'll stop there and we'll solve some more equations in the next video.